In the last lecture, we have seen that voltage is directly proportional to the height of mountain. So a high voltage is the high mountain and a low voltage is a low mountain. When we connect a battery to a circuit, this battery builds up the mountain. And this is known as external potential. So let me just write it. Before that, I'll change the color quickly. Yeah. So this battery is the external force. And this external force causes the electron to move to the top of mountain, and further it is released down doing some work to the bottom of mountain, and where it finally reaches the bottom end of the battery. So the voltage between points A and B is the amount of energy needed or the amount of work done to move a unit charge from A and B. Let me just write it for you. So we have voltage equals to Alright, so voltage is equals to the amount of energy needed to move a unit charge from A to B. So this is our point A and this is our point B. So the amount of energy needed to move unit charge from A to B is the voltage. Now you may ask what this unit charge means. So let me just explain it. Suppose the charge of dq electrons is 1 coulombs. Now what do you think, what will be the charge of one electron? So charge of one electron will be 1 over dq coulombs, and this is known as unit charge. Now the amount of energy needed, so energy is generally represented by W. So the amount of energy needed to move unit charge from A to B will be represented by, say, dW. So let's say the energy of point A will be E of A, and let's say energy of point B will be E of B. So dW can be represented as EA minus EB. So this much amount of energy is needed to move charge from A to B. So voltage is finally defined as dW over dQ. And this is very important result. We are going to solve some really amazing problems using this equation. So voltage is equals to dW over dQ. Now energy is generally represented in joules and charge is measured in coulombs. So the unit is joules per coulomb. Also sometimes energy is represented in Newton meter and charge is always measured in coulombs. So this is one unit and this is another unit. But the standard SI unit for voltage is volts. It is represented by capital V. So voltage is the amount of energy needed per unit charge and it is measured in volts. Let's talk about some interesting results. So before that, let me just change the color. Yeah. Let's say we have a point A over here and we have point B over here. In between there is some small circuit element. It can be any element, your resistor, capacitor, or any other thing. Alright. So we have A and B, and in between we have some circuit element. Let's say the potential difference between A and B is VAB. Alright, so when we write VAB, we say that point A is at higher potential with respect to B. So I'll write it. Point A is at higher potential than point B. Alright, so let's take an example to understand this concept. I'll draw the same circuit over here. So we have point A over here and let's say some small circuit element, and we have point B. Now VAB, that is potential difference between A and B, is 9 volts. So in this case we will say that point A is 9 volt above point B. So VAB is 9 volts, so point A is 9 volts above point B. Let me just redraw the circuit with a slight modification. So we have point A over here and the same circuit element, and this time I'll mark the polarities as negative and positive, and let's say minus 9 volts over here. Now in this case you can say that point A is minus 9 volts below point B. Now minus 9 volts below point B. So this is same as 9 volts above point B. Let's consider this case first. So I'll change the color to make it more clear. Yeah. Suppose I start from point A. Now if I go down to point B, there will be a potential drop of 9 volts. And in this case, suppose I start from point A, there will be a potential rise of minus 9 volts. So potential rise of minus 9 volts is similar to potential drop of 9 volts. So both of these cases are same. When I write VAB as 9 volts, so point A is 9 volts above point B. And when I write VAB as minus 9 volts and with the reverse polarity, then it means that point A is minus 9 volt below point B, or you can say that point A is 9 volts above point B. Both of them are same. When I write VAB as positive, then we can say that VA minus VB is positive and A is at higher potential than B. Now when I write VAB as negative, then VA minus VB is also negative, then it means that A is at lower potential than B. Alright, this is very important. So from both of these, you can say that VAB is equals to minus VBA, and this is very important. VAB is equals to minus of VBA. This is very important, and we will use this concept while solving problems. Alright, we have talked about current and voltage. Current and voltage are two really important quantities. Commonly they are called signals because engineers prefer to call them signals rather than functions of time because of their importance in communication and other disciplines. Just like current, voltage is also divided in two parts. So let me just write it over here. I'll make some room. Yeah. So we have voltage and it is divided in two parts. So I'll write like this. So first part is DC voltage and the second part is AC voltage. Again, DC voltage will remain constant with time and AC voltage will vary with time. The examples of a constant voltage can be, let's say, battery or any other thing which supplies DC power. And the example of AC voltage will be, let's say, generator and the power supply which we get in our home. So all your ACs, refrigerators or any other appliances, they work on AC voltage. And our mobile phones or iPad or any other things, they work on battery. So it is DC voltage. Alright, now we have discussed about current and voltage. Let's talk about power and energy in the next lecture.